we're ready for the panel. I'd like to invite Martin Köppelmann and everyone else that was the previous panelists. So,
maybe you just sit under your name. All right. Yeah. Great to have this panel. So first, one word to Vitalik. Vitalik had agreed to join the panel. Unfortunately, he just wrote, he got sick. So good, well, get well soon. Get well soon for the merge. But let's have the panel. Yeah, with 3 previous speakers, and we saw 3 great presentations. I want to start with where are we coming from, and I looked up the agendas of previous DappCons here, and the last one due to COVID was in 2019. And first, the question to you guys: are you still remembering which talks you gave there?
Yeah, well, you just mentioned me before here, because probably I couldn't remember. But I was talking about identity, and yeah, it's a good thing, because actually in Polygon we finally relaunched the project of identity. We created Polygon ID, and this I think is one of the important projects for the space that's needed. So I'm super happy that this project is happening at this point. It's a project that, as you know, we had to freeze for while we built the first roll-up. We used all the technology from the identity just to build the roll-up, Circom, and all that. But now it's a very amazing team in Polygon that just taking care of that project, and actually they are doing incredible work. And you'll hear a lot about it in the upcoming month.
Alex, do you still remember your talk?
I'm pretty sure it was about ZK rollups, just explaining how ZK rollups work. And looking back, it's been an amazing journey, how much progress we made, as a space overall, making ZK rollups reality first, and then actually very advanced, and things like ZK bridges, that was unimaginable back then.
Yeah, I think it was even kind of pre the idea of ZK rollup. So there it was still one level simpler. It says how ZK proofs can help your dApp. So kind of it was more like a single dApp could have some element or some function that it would kind of put into a snark. And yeah, I think then only then, probably half a year or a year later, kind of there was the idea you can have full rollup, and eventually there was the idea, well, you can actually have the full EVM. And Alex, in your talk, you kind of discussed those levels of compatibility. So let's just make sure we understand that. Maybe I can describe again. So layer 4, or kind of, I think that's what we also started with, was to say, okay, we have code in Solidity and other smart contracts written. Let's make sure we can kind of deploy that. But it's not. What is it not? Kind of layer 4.
Sure. So it's not bytecode compatible. So if you think about compatibility, in the normal software world, you take Microsoft Word or Photoshop written for Windows, and then you want to run it on the MacBook.
Yeah.
What are your options? Option 1 is take the source code, recompile, look into what API incompatibilities you might have, fix those, do see what slight nuances you can introduce, and just recompile and run it natively on this new machine. Second option would be to run a virtual machine. VirtualBox, where you run the same software inside the virtual machine. In the second case, you do not have to make any changes to the compiled code. You take whatever is working already, and you just run it in this kind of simulator environment, which will come with a cost penalty.
Yeah.
You will feel it. It will be slower, tangibly slower, right? But then you don't have to make all these adjustments, don't have to think about the slight differences.
Yeah, Jordi, so that I at least heard that that idea kind of that we can go to bytecode compatibility. I at least heard that first from you at in Paris ECC, I think 1.5 years ago. So yeah, then again the advantage is yeah, there are some compatibility issues that you potentially get rid of at the cost of, or potentially at the cost of some speed, or would you?
Yes, here, as Alex says, at the end it's a balance between compatibility and if you want efficiency. The interesting thing, and this is something that we learned a lot in this last year, is that the loss that you may get in the performance is not as big as you may think. Actually, doing a compatible or a ZK EVM, you know, a ZK EVM, Ethereum virtual machine, so writing a ZK EVM system, it should not be you should not have as much penalty as we thought it could be when we started the project. Because we had this challenge, you know, the EVM was not designed for built in a ZK circuit. We had to struggle a lot, and we have to think in very optimal ways, just doing, you know, just 256 operations, ECDSA. We had, you know, of course, Ketchak, you know, a lot of things that were not designed, and we have to struggle a lot just to optimize those functions. And we come up to a quite optimal way, so that we believe that the differences that will be between non-compatible but with more high performance with a compatible EVM, the difference should not be very big. Again, this is something that we need to see. I have not seen Alex, so the ZK EVM code, and I don't know how this is going to be performed. This is something that we need to check. But what I can tell you is that what we thought at the beginning that this penalty would be, and what actually it is at least 1 or 2 orders of magnitude less. So this is, well, at this point, I had doubts when I started to do with the EVM. We had doubts because of this performance. At this point, I have no doubt. I think this is the way to go.
Yeah. I want to kind of briefly also discuss even the 2 layers above. And Alex, you made the point why that's maybe not even desirable for the roller perspective. I just at least want to make the point, it would be desirable, if we could do it, it would be desirable for another reason, and please correct me if my understanding is wrong, but if we would actually be able to reach this layer 1, it would make a huge difference for running an Ethereum full node, because then you could recursively prove the state. Yeah, maybe, can you describe that, or can the Mina thing?
Yeah, I think if you combine the ZK EVM alongside verification of consensus, you can combine the 2, and I think similar to what Mina's doing, you can verify like the current state of the chain, and you get ability to prove for the state transitions and also the consensus. I think there's some problems with that, like you have to be worried about long-range attacks, and I think the details there actually kind of matter in terms of like how do you implement this like fork choice rule and stuff like that. But I think certainly when you have both, it should be possible.
I just don't think it eliminates the need to actually run the full node with the full state, because you need to execute it fast. Like you cannot wait and have this lag between the latest state and the finalized state with the proof. So like it would still not solve, it would not eliminate all the problems there. But yeah, that would be possible.
It would at least probably eliminate the problem that currently, right now, it can take many days or even weeks to get a node synced. Yeah.
And very important also for like clients. You know, right now, like clients, they need to synchronize the headers, and this takes a while, and it's the batteries, and it's expensive, and so on. With this, you just get a proof that this is the last block, and you just verify that, and you are synchronized, so you don't need anything else, and that would be amazing. And this is clearly the way to go. We are still a little bit far from that, but we are much closer than we were.
Cool. Then maybe let's push the topic by side, and kind of in 2 years at DappCon we can hopefully then
But I
talk about
just want to add one thing. Like there is a simpler way to solve it. If Ethereum is embracing layer 2 centric roadmap, roll-up centric roadmap, what you could do is you could eventually just like limit the block size from 12 million gas to like whatever it takes to verify just a few zero knowledge proofs, right? And then like the access to the state could be increased multifold, so that it's very, very expensive to use layer 1 directly. So you push everyone into layer 2s, which should be decentralized, broad, and offer variety and offer like all the functionality with high speed, high throughput that you want.
That brings me to the next topic. Could that be a desirable solution? And the thing why I have at least kind of doubts about that, or at least say, well, there should be probably kind of other approaches, and well, with Node Chain we are actually going another approach, is the question of who can actually build blocks, and how realistic is that to decentralize. And I think, or maybe you can comment directly of like how well, who will be able to build blocks, or kind of a Penn state, or therefore kind of make sure that a chain is censorship resistant.
In the layer 2? Yeah,
Yes.
in the layer 2, here the solution, and this is, I think, is quite common in the optimistic rollup and in the ZK rollups, is this idea of the sequencer, splitting the sequencer and the prover. The prover actually cannot do anything. It just takes what we call it an implicit state. So once the transactions are sequenced, you already have a state. The transactions are actually final. The thing is that this state is not available on chain, so you cannot withdraw funds, and you don't know. But actually, the state is there after it's sequenced. So the only thing that have to do is just prove that this implicit state is correct. Okay. And then this sequencer, for this sequencer here is the dilemma. It's if you just use, and here, we designed this proof efficiency. Proof efficiency at the end is a decentralized sequencer that runs on top of layer 1. With this idea, so with this decentralized sequencer on top of layer 1, you will never be able to be better than the layer 1 that you are running on top of that. So if you want to be better, because you want to have better finality, because you want to have if you want a different balance in the trilemma, in the layer 1 trilemma, you need to build like another system in front. It can be a centralized system with all the, you are in the trilemma, you are in one corner of the triangle. You can build another blockchain, a consensus mechanism to have different properties in this dilemma, or you can use layer 1. But what looks clear, I don't have a mathematical proof for that, but what's clear is that you will not have better properties. If you are layer 2, you will never have better properties than the layer 1 you're running on top of that. So the development of these consensus, these sequencers, I think this is one of the interesting things that needs to happen. This is common to optimistic rollups and ZK rollups, and I think that we should put a lot of effort in that side, because, well, it's a temporary, it's a temporary, because once the sequencer is put in layer 1, then you already get all the properties of the layer 1. But for temporary, especially for latency and even for throughput, this is going to be one of the limitations there. And I think this is one of the interesting topics that will happen in the layer 2 in the coming times.
So let's try to nail this down. So essentially, if any system is a layer 2 on Ethereum and it says it offers 1 second finality, it cannot be true, right?
Well, it's going to be probably there will be some assumption, maybe, that you trust a centralized sequencer. So if you accept that assumption and it's okay in your application, then that's fine. But you probably have to get some specific assumptions.
or you decentralize the sequencer,
Right.
and then you add some economic weight to the sequencer. So they put some bond, and if they revert transactions that were committed but not yet finalized on Ethereum, they will have to pay.
Right. So
the
essentially,
price.
you implement its own consensus
Yes, correct.
system, and then you can have at least the guarantees not of the L1, but of, well, that is.
Yeah, but then the entire state of this validators of this decentralized sequencer is only securing a few transactions in the flight.
Right.
Not all of the transactions in the long
Right.
range of like all accounts, but only a few recent transactions that could or could not be reverted. So that's a lot of stake for a very small amount of value, which gives you a very high security.
And I think, Uma, that would be a good transition to lay out what kind of the bridge you have been working on offers, and also what it does not offer, because I think, yeah, maybe you can extend on that. So he said all the transactions that have previously are secured. How does it look like in this bridge?
Yeah, so I think for the bridge, especially thinking about rollups, you can't, for a rollup, if there's transactions in flight that have not been validated and secured by like the main chain, if we're bridging from like rollup to rollup, for example, you can't get the in-flight validation until it's like posted on Ethereum, for example, if you're validating Ethereum block headers on a different chain. What you can do if there is like a decentralized sequencer that has its own consensus mechanism is if you want, and if you trust like that level of security and you're willing to do those assumptions for like the faster finality of the rollup, maybe you could implement that consensus algorithm or verification of that consensus algorithm on like a different chain as well. So I think one thing we're really excited about is when rollups do decentralize the sequencer, maybe you can take advantage of that for like faster finality between rollup bridging in like a similar manner. But in general, I think decentralization of the sequencer is very important, especially for censorship resistance. And I think it'll also be really important in the bridge as well when we're generating these headers and generating these proofs. I think it's really important.
Yeah, I mean, my perspective is a little bit, we are like on Gnosis chain, we are starting with the extreme of decentralizing the sequencer, which means we have 100,000 validators, because that's kind of that's what it is. I mean, that's kind of, in a way, each validator is a sequencer that's randomly chosen. And yeah, we were able to come up, or you were able to build this bridge, but yeah, that it has lesser security guarantees because, or maybe you can expand on that. So again, Alex said the old state that can never be meddled with. In our case, kind of, if the validator set.
Yeah, so if the validator set of Gnosis chain probably has like less economic security than full Ethereum, of course. So if you're bridging from Gnosis back to Ethereum and validating the consensus of Gnosis, if there's an attack on Gnosis chain or a reorg or something like that, then you get that level of security when you're validating the consensus on Ethereum. So you're not able to inherit the full. Just because you're bridging from Gnosis to Ethereum with this does not mean you're inheriting full Ethereum security. Of course, it's just the security of the consensus protocol.
Right. So we're proving the state is canonical. We are not necessarily proving it's correct. Maybe just as an outlook, maybe eventually it's possible to combine those two things. But yeah.
But do you actually prove that the state is canonical? Because what happens if there is a fork? Which fork will be canonical? Right,
like a hard fork.
Yes.
Yeah, I think dealing with hard forks in this design, we are thinking about that. Like a hard fork is it's like a social thing, right? Like the old chain is just as valid as the new chain, but everyone agrees. Yeah, if people have ideas, I mean, we've thought about, you can have some governance over what the hard fork is, right? That you keep track of the fork ID or something else. But you do need some like social mechanism to keep track of which fork this like client is going to keep track of. Because the old chain is as valid as the new one.
And I would argue if we talk about hard forks, then in a way your system or kind of ZK EVM system suffers the same issue. I mean, theoretically, if there's a hard fork on Ethereum that, I don't know, kind of removes.
No, rollups are immune from forks because the rollups, like you will just have two versions of the rollup on two different forks. Okay? It's a problem for
Right.
bridges, not for rollups, because the rollups, what we call a bridge on a rollup, is actually just the basement, the fundament on which the rollup is connected to its underlying layer one. But you never detach it from layer one. It's not a separate entity, right?
Okay.
So forking
Right.
layer one will
I see.
automatically fork the rollup as well, with all the assets.
Yeah, right.
And with all the consequences.
Sorry?
And with all the consequences, yeah, maybe there are, maybe you can have a USDC that's consensus to run in one rollup, and Tether, it has a consensus to run in the other rollup, and yeah, that perfectly can happen. I hope not, but
Yeah. Maybe next, let's talk about, because that touched already the topic of upgradability. What is a realistic strategy to roll out those systems? And I can just share our experience years ago by just developing something like Zenosis Safe, which is probably 1 or 2 orders of magnitude less complex. I'd say that was still a process of 1.5 years to get it to a point where it was really broadly trusted. And so now I guess the question is, those systems, and the question goes to all three of you, again, that are so much more complex, how can we roll them out?
we are writing this to be decentralized. Okay? So we want this to be absolutely even governance-less. So it's just a system that works, the system is from the humanity, and the system works alone, and you are not even part. You created that, but that's it. Things happen. This is the idea of the system that we are building, and this is, of course, the goal that we have. Reach that point is a long track. Right now, let's try to launch some production systems and see how they work. There is a long path to arrive there, but something that we need to have present. All the projects need to have it present that we are going to that direction. We want to have a plan for going that direction and stick to the plan because it's easy to get lost in that. It's things work, you don't touch it, but we need to have always in mind that the end goal is to decentralize. The end goal is to create systems that are common goods.
Yes, it's a really hard question for us because there is really no good solution. Like the ultimate solution does not yet exist. The problem is that you want to protect against potential vulnerabilities, but if you who do you give the right to make instant changes to? If there is a certain group of people, or a community who can do those changes, then let's say it's governance, then they could potentially do all kind of malicious changes as well. So how do you balance how do you prevent people from doing malicious changes, but being able to respond to malicious actions? What we came up with in ZK Sync, what we currently have in place for version 1, and we will be embracing for version 2, is the core developer team can only initiate upgrades with a time lock. Mm-hmm. And it takes multiple weeks, so everyone can see the upgrade, and if you don't like the upgrade, if you don't believe it's properly audited, or you can look at the code yourself and decide whether you trust it or not, you can always withdraw your funds through a priority queue mechanism which is permissionless and trustless. There is no way to censor it because you do it on layer 1. If there is a vulnerability which requires an urgent care and instant upgrade, then in addition to the team initiating an upgrade, there must be a consent from what we call a security council, where We have a number of highly prominent public figures from the Ethereum community who have to approve this upgrade with a certain, pretty high threshold. That is, for now, the best thing we can have. The ideal scenario would be if we could fork our L2s, but then we can't really fork the hard assets that are locked in the contract on Ethereum. However, we could fork all the derivatives. Like if we never used directly Ether, but we used something that is emerging like NFTs or any kind of assets that are minted directly in the L2, this would not be a problem. So maybe that's a solution. Maybe the solution is to say, okay, like in the L2s, you should prefer using the virtual assets, derivatives, rather than actually bridging hard Ether. Not sure.
Yeah, one of the things that we implemented in Hermes 1, and I think it's an interesting thing, is that we limit the ratio of exit outputs. So if you want to exit $100, is decentralized, so you can do it. We cannot stop that, but we limit the quantity of dollars per hour the system allows to withdraw, and this combined with some kind of escape hashes. This allows us to do something on there. But the idea is to try to do a cap, try to make to control the risk that you are assuming. So for this, you need to assume some risk in order to grow. So you say, okay, maybe there are some vulnerabilities, but we need to go forward. So the idea is how we limit this risk and how we control this risk. And here, there are some mechanisms, none of them perfect, but at the end are in the middle solutions just to handle this bootstrapping process, which is, well, this is quite complex to handle.
Does it mean that your team has an ability to censor funds that are locked in Hermes 1? And like not
They
like if I have $1 million,
they are sent to no, not that way. They are sent to, there is an intermediate smart contract for withdrawal, so small funds can always go through. But for the big throw, you can choose to go to via this one, and this one is the one that can be set up. But it's up to you to go to this, to do this withdrawal that goes to, that then you can do the escape hatch. It's not the escape hatch to the smart contract, it's a escape hatch to a temporary smart contract that you can save your funds. Because the problem of the time lock is that if you find a vulnerability, maybe it's too late. You cannot react to that. With this system, you can, the people can do a withdrawal to this place really fast, and then, or can withdraw themselves, or can withdraw to this place really fast, and then from here do it a safe. So go to a safe machine.
But it's time locked, right? You cannot.
It's a time lock. It's a combination of both things. It's a combination of time lock and rate limitation of the rate that you can withdraw without asking, without doing anything.
Sure. So if I have a large amount and I try to withdraw, I will not be able to do it immediately. It will be subject to time lock, during which your team can upgrade the contracts and actually
we can buy time. The idea is that we can buy time to try to fix the system, or just try to maybe via UI, or just we try to do
I understand, but like that just automatically gives you the right to censor, and this is the right we, for example, don't want to have.
We cannot get the funds, so the funds are locked there. So we just stop withdrawings.
So then the attacker will have the funds, right? And then how can you prevent?
If you stop the withdrawals, then you have one week, and then you have to take a decision. And in the last thing, it's escape hatch. That's not going to go to us. It's going to go to a third party.
I actually feel like
but it's a hard topic. But at the end, these are solutions. At the end, this is not good. None of them, right. All of them all of these solutions have its problems. At the end, are just intermediary things just to handle this bootstrapping, so that's not fully centralized, so that you cannot take all the funds, and at the same time you have some protection. At the end is systems to balance this.
I fully understand, and I would actually say, kind of at this kind of early stage, at this technology, I would probably trust the system where the developers can make changes. Because I would say the risk at this early stage is higher from, is higher from, still bugs than malicious developers. Again, long term, well, that definitely needs to change.
I think in the long term, in the short term, like time lock or governance or these kinds of mechanisms are really important because the systems aren't really tested. But then over time, as they get more hardened and there's better auditing support and people understand them better and empirically they've held up, then I think you can move to a future where you remove these safeguards.
Yeah, maybe here, connected to that is that's also kind of a security or and rollout strategy question is the question of open sourcing. So I think, yeah, both of you have open sourced. What's your strategy, Alex? Or what?
We are going to open source everything after the code is audited, but we're going to open source it under permissive license and just like zkSync 1 is completely open sourced under MIT Apache license. You can take it, fork it. There are a number of forks. What we realized is people were forking the system before it was audited. Before there was a fork that launched their token before we actually launched the new version in production, and they had some bugs there that were not yet fixed, and we had to inform them and let them fix those things. So we decided, okay, we're going to open source everything at launch once we have everything is ready for people to use. But I have a question to Jordi. You decided to open source it under copyright. Why did you take this decision? Are you planning to change it to permissive open source so people can actually use the code?
Because we want to avoid this, but we want to avoid this. Somebody just launch with bugs in there, but at the same time, we want the people to have access to the code, and we want the people to review the code. We want the people to audit and to check and to know before using the network what they are using. And for us, it's very important that before launching, at least have some time to the people to review what's in there, to take a look what's in there, to check what's in there. And that's for me, this is fundamental, but this is...
Cool. Then let's, after discussing kind of all those potential issues and problems, so let's do finally the outlook of kind of, let's say, 2, 3, maybe 5 years, how each of you, how do you envision kind of the blockchain landscape will look like? Kind of, will there be one chain with just rollups on it, many chains? Yeah, maybe asking in the round. Or you don't know. I mean, that's also valid.
So what I know is that 5 years is very difficult in the space to think. But what I see is that in maybe 1, 2 years, it's going to be many, not many, but maybe, I don't know, 3, 4, 5, 6, 7, 8 rollups with different properties and with different things. And this is what I would expect. And I think this is the best for growing the technology. That many rollups are running there, and that many rollups just we learn from one, we learn from each other. We see the properties, we see what are the trade-offs, we see what are the things that are good or that bad. And this is, I think, this is the most important thing for the mid-term. In the long term, we need to see the performance. Maybe, I don't know, maybe in Ethereum there is a standard rollup and then everything else is done. I don't know. Or maybe these rollups, we have a good communication, so a good inter-rollup communication, and we go to a system that's more multi-rollup way, but I have no clues on that.
Well, I would begin with saying that I believe that in the midterm, Ethereum will win it will be very clear that Ethereum won the L1 race. Right now, it makes a lot of sense to have alternative L1s that offer alternative properties that are more higher throughput, something else. In the midterm, once rollups actually take over and we have dunk sharding, costs are a lot cheaper for rollups. Ethereum will just have all these properties which you can have on Ethereum directly. So with regard to rollups, we will have indeed some period of experimentation with multiple rollups. In the end, we'll have a very interesting dynamics with what concerns the layer 3s and the hierarchy of chains on top of rollups, or like on top of the ZK systems. Because with zero-knowledge proofs, the most interesting property is the recursive succinctness that we can leverage to create truly infinitely scalable systems. But that changes the dynamics in a way that takes a separate discussion to explain, but we will have some very different properties of the network effects that will play a role, and then we will see how. Like, so what I believe, like, we will be thinking about the rollups very differently in a year from now, once we have the first layer 3s taken off. That's my prediction.
Yeah, I think as Jordi mentioned, it's really hard to predict 5 years in the future in this space. It's an eternity. I think maybe an argument for different L1s to exist is maybe people don't want to be locked into the EVM model. Of course, rollups can be non-EVM as well. I think it's very hard to predict. Empirically, it seems like there is demand for these different chains with these different properties right now. And yeah, I think you just have to build and see what happens.
One argument I'll try to make for another, in a way, L1 is to say that, in my view, whenever you build a rollup or kind of something on top, layer for layer, it's pretty clear that the layer above will be less decentralized, or well, less decentralized than the layer below. So kind of, if you build higher and higher, you will build into centralization. So I would say it is, if you kind of start with kind of decentralization is the first thing you care about, and again, I think the block production is something I would say other L1s will have its value, probably. Who knows? I think we all don't know.
I think we will converge. I think the layer 2s will develop properties similar to alternative L1s, and alternative L1s can develop properties similar to rollups, and they're going from different directions to the same point. They eventually they're going to meet. Maybe we will see Gnosis chain with like some very specific properties that make it very valuable on top of Ethereum, like as a ZK chain, maybe. You know, like this could happen. So
no, I mean for sure, and that is this possible future, and I think we termed we use the term layer 1.5. Not sure if it's a good one, but kind of if we would also introduce those ZK EVM proofs and have that bridge, then kind of it becomes they become pretty similar actually, or they merge together. Thank you very much to all of you, and I think we would like to open up it for questions from the audience again. Is he there? Is he their hand in there? Yeah.
How do you feel about DApp-specific chains? Are they going to become popular, and how do they fare against rollups?
DApp-specific chains, how we feel about them. So I think DApp-specific chains are a thing. They will exist. They have their niche, simply because generic chains will always suffer from problems like MEV bots, etc., that will specifically create like disproportional load on the parts of the chain capacity, on the chain total bandwidth, pushing out the application-specific, some niche cases out of those chains. So like, I think they will be there. I think they will be also running on ZK. I think everything eventually will be running on ZK. We'll have a single one world-coordinated ZK tree hierarchy of chains that all converge to the single proof that everyone verifies, which is probably going to be like Ethereum, fully succinct Ethereum proof, where you can check the validity of all the transactions on all chains, and then specifically explore certain chains and see what happened there. But those chains will be separate. They can be roll-up based, they can be Validium based with external data availability resources that are secured specifically by operators or by validators or by users of those depth-specific chains. But yeah, I can totally see that this happening for social networks, for certain games, for some microtransactions, for some specific payment networks. Even if you just take payments, the very basic use case, you can't really have all of the world's payments happening on a single monolithic system or on a single within a single consensus, because we have some systems in the world like Alipay handles at peak times 140,000 transactions per second, just one single network. Visa peaks at I think 40,000 transactions per second, and those are niche systems that only cover specific parts of the world. If you take everything and then you imagine digitalization of the world going on with acceleration and penetration of internet embracing all of the countries, we will need to separate them in payment-specific chains just for the specific region, just for specific use cases. So yes, we'll have a lot of them. And that's payments alone. Many more use cases on top.
At least in the short run. Maybe in the very long run, blockchains become very much a commodity, and then everything can run in a single chain. But this is long run.
I'm curious about the panelists' opinions on alternative approach like optimistic rollups, whether they can coexist with validity ZK-based rollups, and whether a hybrid system would be interesting.
For optimistic rollups, I feel like the main con is the fraud proof challenge period, which ZK rollups obviously do not have. I think similarly, an optimistic bridge also has that similar issue that a ZK-based, proof-based bridge does not have. So I view that as the main con. And if the ZK proof-based system is going to be as performant or close to as performant and not as is not much more expensive to run, because proof generation does cost money, you probably do need custom hardware, then I think the advantages are clearly in favor of the validity-based rollups.
The end here is the difference. So in the ZK, you are paying the proving cost, and in the optimistic, you are paying the capital cost. Capital cost is you cannot read out of that, because this is what secures the network. So this is very difficult to improve this. In the other side, in the ZK rollups, the proof cost can be improved a lot. There is a lot of margin to improve the proofs. So it looks, and here we're a little biased. We are in a ZK panel here, but it looks like for me, it looks like clearly that the cost of the proof will be minimal, and then it will make no sense to have. So for the same price, you have a ZK, so you have instant, so you can withdraw instantly. So I don't think it makes sense to have optimistic rollups in the mid run. In the short run, while we are building the proofs, and they have some other advantages. It's much easier to build an optimistic rollup than a circuit to validate that. But that's my opinion. Again, biased, and here maybe in the panel should be something from the optimistic to talk to explain his side.
Cool. Then again, thank you. Thank you all very much, and see you maybe in 2 years or 3 years again, and we kind of discuss how this goes further.
Pandemias in the middle.
Good. Thanks.
Thank you.